Final exams mostly multiple choice, but you're also going to have some free response questions. These were actually pulled from past final exams. These are actual reactions I put on final exams. Yeah.
Are we working on these right now?
No, we're not working on those right now.
Are we gonna have a review day?
Yeah.
Like where we can just ask.
We're working on it right now.
Oh yeah, can we get a picture? Oh wait, no, it's like.
All right, let's look at this next reaction here. This next reaction is going to be ethanol. Ethanol, the formula for ethanol is CH3CH2OH. Potassium permanganate, what's the formula for potassium permanganate? And hydrochloric acid? Okay. All right, so what is going to form from this reaction?
Probably get some H2O.
How would that break?
What is ethanol? The H2O with the.
This one you do inventory, right?
Yeah. This one, a couple of things stand out. If we did the inventory, let's go ahead and do the inventory. Ethanol doesn't break up into ions. It's molecular. Potassium permanganate does. It breaks up into potassium ions and permanganate ions. Hydrochloric acid breaks up into H plus and Cl minus. And then we have one more thing in the inventory. What is it? Yeah, water. When we look at this reaction, or potential reactions, what's the most reactive species you see?
Probably the K.
What aspect reactive? Like oxidizer?
Anyway, oxidizer, reducer, acid, base. What's the most reactive?
Probably the
H2O might be the most reactive oxidizer.
Isn't Cl the strongest reducer? Oh no, not reducer, oxidizer.
CL is one of the least reactive I see.
Potassium's least reactive too. It's an ion.
What's the most reactive? Does anything stand out? If nothing stands out, this is why you want to get familiar with the chart. The more familiar you get with the chart, you'll notice something's going to stand out. What is it? MnO4. This is a powerful, yeah. So when I look at this, I see strong oxidizer. Strong oxidizer wants to oxidize something. Okay, ethanol is not on the chart, but you know something about ethanol. Is ethanol flammable or alcohols are flammable, right?
Yeah.
Well, a combustion reaction with alcohol, it would be alcohol plus what gives us CO2 and water? Alcohol plus oxygen. Oxygen is an oxidizer, right? That's where the term oxidizer comes from. We have two oxygens here. Which oxygen would we use?
The strongest one.
The strongest one, this one.
Why strongest?
It's always the strongest one. The strongest one will always take the electrons first before the weaker ones.
So you have to like assume things like that when you have like.
You don't really assume. Which one do you think is going to, which piranha do you think is going to, is going to eat most of the meat? It's going to be this, usually the strongest ones will.
No, I meant like with the ethanol, like you have to think about it like in terms of
Right.
if like it mixes with O2 to make water.
Right, well, one chemical property we know about ethanol is it burns. If it burns, then it's being oxidized. What's the oxidizer? Oxygen. Is oxygen the most powerful oxidizer? Are there more powerful oxidizers? There are more powerful oxidizers. And so immediately when I look at this, I see a potential explosion. That is, permanganate is an even more powerful oxidizer than oxygen. And you know, the combustion reactions, one combustion reaction we've been looking at over and over is this. And so what we want to know is this. What we want to do is we want to do a mix of factual knowledge, memorization, and theoretical. And so, is methane flammable? Yeah. Well, what makes methane flammable? Well, methane's flammable because we're going to react it with an oxidizer. What do oxidizers want? Like oxygen. Oxygen wants electrons. Does methane have electrons to give? Well, let's take a look at the oxidation states. What's the oxidation state?
Plus 1.
Plus 1 and?
Plus 4.
Not plus 4.
No?
Minus 4.
Minus 4. So does carbon have electrons to give? Yes, carbon has electrons. We call this carbon electron rich. There are two ways I showed you how to get oxidation states. This was one way. What was the other way?
With the chart. With the periodic table.
Yeah, with the periodic table. That's kind of this way. There's another way based on Lewis structures. Do you remember how to do it based on Lewis structure?
Just all the free, the ones that aren't bonded.
Go you write it out or draw it out.
Oh, yeah.
There
you
are
like
3 ways to
circles.
count electrons in Lewis structures. What were the 3 ways to count electrons in Lewis structure?
Box and all.
Yeah, by boxing. So we have the octet duet. That's one. What's another way?
You had an equation for one of them, like where you count them all. and
Yeah,
three
what
ways.
was that called? What was that called?
Determine the charge.
Yeah, what was the charge called? Formal
Formal
charge.
charges.
Formal charge.
So that's what the box is.
Right. So a formal charge is so we had octet, we had formal charge, and we had what was number 3?
Net charge?
No, not net charge, not duet.
Was it the
You guys are too. This is too slow because if you're, let's say, if you're going, think about this. If you're taking a time test, you need much more rapid recall. If you're taking a time test, you know, when I went to UCLA, all the tests are timed. Like they do this, they make you put the pencil or pen on the table, and then once the time starts, then everybody can lift their pen. When time's up, if your pencil doesn't go down, they can come over and knock off points off your test, like minus 10 points right there, if you don't put your pencil down. And it was a kind of a shock because, you know, I knew how to do the problems, except I was too slow. I was slow, which meant my grade was bad. If you're slow, your grade's going to be bad, regardless if you know the problem or not.
It's a bad system.
It's a bad system. I don't like it, but that's the way it is. So you need. So what I had to do is I had to do like drills. You know, exercise drills. You do those drills. You keep doing those drills, and you get faster. You have to drill. Otherwise, you're not going to be successful on time tests. You know.
Is the
So-
last one the formula?
No, the last one is time is ticking. The last one is.
We failed.
This is too much. This is too much. You're already falling behind. It's like a marathon. You're already way behind the leaders. You're way behind. You're getting farther and farther behind as the time is ticking. So that's the way I felt.
But the
Hey, you
turtle
know what they
eventually
say,
gets
slow and
there.
steady.
Eventually,
Yeah.
I'd make it to the end. You know, who wins the race?
The turtle.
Yeah, but they don't let the turtles win.
Yeah.
They don't let the turtles win. The turtles lose.
Bye.
Are
So-
they like automatically just disqualified?
If you're slow, you lose. You lose a lot of points. It's not fair, but that's the way it is. So you got to have. They figure this, there's lots of discussion, you know, about this kind of thing, and they say, well, you know, they didn't really know it well enough. That's why they're slow, you know. But that's not always true, you know.
People just work to
Right.
What's the last one?
And so yeah, there's differences in philosophy. So, but anyway, I'm still waiting for the third way. What was the third way of counting
So
electrons?
the first way was
First way was
Lewis Fraser.
octet duet. Second way was formal charge. Third way was
This way? I'm using the
Formula?
no. When we're talking about Lewis structures, the last way was
The bonds?
Huh?
Is it counting the bonds?
No, oxidation state. Oxidation state is winner take all. So winner takes all. Carbon versus hydrogen. Carbon wins all electrons. Carbon gets 8 electrons. Its oxidation state is -4. So so you can see in methane, carbon's very electron rich.
Why
These
is it-
days. Why -4?
That's not.
Winner take all in oxidation state.
So wouldn't it be minus 8?
No, because it's supposed to have 4. It is 8. It's not -8. It normally has 4.
Yeah.
Then it has an extra 4, and so that extra 4 gives it -4.
So which is the one where you showed us like to count the bonds and then depending on the bonds,
Formal chart.
divided that by 2?
It's formal chart. So we could do the same thing with ethanol. Ethanol is a bit more complex. We'll draw out the Lewis structure of ethanol, and we're going to look at the oxidation states. So when we do this, winner take all. Carbon versus hydrogen, carbon wins all. Carbon versus carbon, well, that's going to be a tie. So we aren't going to have winner take all here. So how many electrons does carbon end up with?
4.
So -4?
2, 4, 6, 7. How many is it supposed to have?
4.
4. It has 3 extra. If it has 3 extra, it's -3. This carbon's electron rich, I'm going to say. This carbon,
Same thing.
no, it's not.
Oh, what?
Carbon versus oxygen, who wins?
Oxygen's
Oxygen
also-
wins.
So that has a minus.
So 2, 4, 5, this is -1. This is semi-electron rich.
I don't remember doing this either.
Oxygen is
0.
-2. It's got 8. All the hydrogens are +1. This is the oxidation state. Now, when we burn ethanol, what do we burn it to? We're going to form,
H2O, CO2.
yes, CO2. What's the oxidation state of carbon in CO2?
+4.
+4. Can we go higher? You don't. Can we burn it to carbon trioxide rather than carbon dioxide?
No.
Is it possible or not possible?
Oxidation only goes up to +4.
Yeah, it's not possible because this would bring it at +6. +6 is not possible for carbon. And so this has been oxidized completely. So this is called complete combustion. Complete combustion is going to form CO2 and water. Do you think we're going to have complete combustion here? Well, is permanganate stronger oxidizer or weaker oxidizer than oxygen? It's stronger.
For sure gonna have
Yeah, for sure. And so we can burn the ethanol in the total absence of oxygen. This will burn and potentially explode. You know, methane can potentially explode. I think I showed this already, but
I heard some people collect methane from from their animals and stuff like farms.
All cows produce
Yeah.
methane.
And they use it for
They're
stuff.
farts. It's literal methane.
How do you catch that?
Funnel it.
I mean,
Did you say you funnel it?
well, I guess
I guess that's one
So
way.
you put the funnel to
It'll be a room and then they're like in a room.
Or you have it in a room with a ventilation system.
Go
My
inside
dad said
this
he
cow, funnel.
sit on that rancho and be like people like that. They know.
No, es una vaca ahí.
Did you guys remember this? A 5-story, you want to see the remains of a 5-story apartment building?
Someone left like their cell on
They have gas.
Yeah.
biggest fear.
This was a 5-story apartment building. 4 people died.
Would you stop with that?
That, yeah, that's the remains of a.
Would you stop with that?
So this is methane with oxygen. What do you think about this? This is electron rich. This is permanganate. Permanganate's even more powerful, so you could have an even more violent reaction with this. Right. All right. So when I look at this, even though ethanol is not on the chart, I know from experience or from just factual knowledge or just from past things that I've seen that this is a potentially violent redox reaction here. You guys see that? Now, the HCl is important there because in order for permanganate to work, what do we need?
Yeah.
We don't care about the Cl. In order for the
A
permanganate,
reducer?
in order for the permanganate to work, we need H+. And so the HCl is going to provide the H+. So we're going to get a redox reaction here.
So
And
there's
delete.
two redox reactions happening at the same time.
What's that? Oh, two questions around.
Oh, go ahead.
Well, so there's two redox reactions happening at the same time.
No, there's only
There's only one.
there's only one. All of these you could have multiple redox, but we don't want multiple redox. So all we're going to do is we're going to pick the strongest oxidizer and react it with the strongest reducer. We could pick the weakest reducer and react that with the weakest oxidizer. But that's not the most probable reaction. The most probable reaction would be the strongest. We have a whole bunch of oxidizers and reducers, so we can mix and match.
So what it means?
We always pick the strongest. We don't pick because the strongest is the most likely to occur.
So with the strongest oxide, the water reaction that would be the same.
No, you do it systematically. Is ethanol electron rich or electron poor?
Hey, Professor, what's the redox reaction again? Redox, what does that mean?
Just a second, we'll finish that. I'll get back to redox. Potassium ions?
Oxidizing agent, but it's weak.
Permanganate with H plus?
Oxidizing agent.
H plus alone?
Reducing agent. Oxidizing agent.
Just look at the chart. Chloride?
Reducing agent.
Water?
Both.
Which is the strongest oxidizer?
Oh, and then O4 and H plus. When they're together.
Now we have 3 reducers. If you're going to build a campfire, which one do you think is easiest to burn? Ethanol, chloride, or water?
Ethanol.
Ethanol. So we don't even though this is not on the chart, we could use our experience to tell us that this is going to be the strongest reducer. Because have you ever tried to burn salt, sodium chloride?
Yeah, it's not possible.
It doesn't
right?
burn.
I think.
Have you ever
that's
tried
why
to burn
also put out
water?
fires, right? I mean, it's water. I don't know how you do that.
It's not going to be easy. And so the most likely reaction is going to be between these two. That's it. Now, what does redox mean? Redox is short for reduction, oxidation.
So this is the first time we're getting it. So you're taking the oxygen.
So one has to be a reducer, one has to be an oxidizer.
Right. This comes to something called oil rig, which we'll talk about.
Oxidation is loss.
Yeah, oxidation is loss of electrons, reduction is gain of electrons. Right. We'll talk about that more later.
Is that accurate here?
Yeah, that's accurate. All right, so how do we figure out what's going to happen in this reaction? How we figure out what's going to happen in this reaction is going to be the next level up that we're going to do next time.
We would
but-
put the MnO4 plus 8H plus 5E minus.
Exactly, good. That's what we do.
But if ethanol's not on that chart, what do we do about that?
Ethanol's not on that chart, so what do we do? That's a great question. Because this one's on the chart, so all we have to do is copy it down. And so to copy it down, we just write it over here.
So will we write out CH3, CH2OH plus oxygen?
I'll do it.
And then
Just one
that's
second.
the formula, or?
Well, actually, I'll do it now since you're curious about it. The permanganate plus 8H plus how many electrons?
5.
5 electrons goes to
Mn2 plus
Mn2 plus 4H2O. Okay, but the problem here is what do we write for the ethanol? Ethanol's not on the chart.
Don't you do a combustion?
Yeah, would you write it out in the question?
It's like ethanol plus O2 is equal to.
Okay,
H2O
we
plus
know
O2.
we kind of have an idea. If we oxidize ethanol, what does it get oxidized to?
CO2 and
CO2. I'm just going to write the CO2 because that's what's going to happen. And so if we oxidize the heck out of ethanol, it's going to form
carbon dioxide.
carbon dioxide. Now, this is called a skeleton. Now, it's easy. Once we have a skeleton, then it's easy to figure out what the equation is. We just follow certain steps for skeletons. These are the steps for skeleton. let me write it. Let's just take a look at it here.
Do you have the balance skeleton?
This is for balance. We'll start with number 2 here. The steps are this: balance all elements other than hydrogen and oxygen by changing the coefficients. So how many carbons do I have on the left?
2. We need 2.
And so I'm going to change the coefficient here and put 2 CO2s. Balance the oxygens. So how many oxygens do I have on the left? 1. I have how many oxygens here?
4.
2. 4. So 1, 4. I'm going to do this. I'm going to balance the oxygens by adding H2O. So now I have 3 oxygens. You see that?
Yeah, I have that.
Okay, then balance the hydrogens. So I got 6 plus 5. 6 plus 6 is 12 hydrogens here. I have no hydrogens here, so I'm going to add 12H plus, like that. Then I'm going to balance the charge. Ethanol is neutral, water is neutral. CO2 is neutral, this is plus 12. By adding electrons, so this is 0, this is plus 12, I'm going to add 12 electrons here. And then I'm done. And so the half reaction for this is this. It's CH3, CH2OH plus 3 H2O liquid yields 2 CO2 gas plus 12 H plus 12 electrons. Does that look right? Well, I don't know, but I could check it. I could check atom balance and charge balance. So I got 2 carbons, 2 carbons. 3, 5, 6 plus 6 is 12 hydrogens, 12 hydrogens. 1 plus 3 is 4 oxygens, 4 oxygens. Charge is 0 plus 0 is 0. 0 plus 12 is plus 12, minus 12 is 0. And so it's balanced. This is what we call a balanced half reaction. Okay, once I have the 2 half reactions, then what do? I combine them. And so this one needs 5 electrons, but this one produces 12. And so what I'm going to do is I'm going to cross multiply. I think that's going to be the easiest. And so I'm going to multiply this one by 12. So I'm going to get 12 permanganate, then 12 times 8 is 80, 96. 96H plus, 12 times 5 is 60, 12 manganese 2 plus, and 12 times 4 is 48. Okay, this one I'm going to multiply by 5. So I'm going to get 5 ethanols, 15 waters, 10 CO2s, 60 H plus, and 60 electrons. Okay, now I'm going to add them together. And so I'm going to get 12 permanganate plus 96 H plus 60 electrons. And then I'm going to add these plus 5 ethanols plus 15 waters. Okay, produces 12 Mn2 plus 48 H2O liquid plus 10 CO2s plus 60 H plus 60 electrons. All right, the electrons have to cancel. So I got 60 electrons here, and those are going to cancel the 60 electrons here. So electrons cancel. Then I'm going to look for driving force. Is there a driving force for this reaction? The driving force is best done off the half reactions. So if this is my oxidizing agent, then that means this is my conjugate reducing agent. And if this is my reducing agent here, then this must be my conjugate oxidizing agent. And so we're going to label it on this reaction here. Permanganate and H plus, this is oxidizer. Ethanol and water, this is our reducer. Mn2 plus and water, this is going to be our conjugate reducing agent. CO2 and H plus, this is our oxidizing agent. Okay, the next step is we ask ourselves, what's a stronger oxidizing agent? Permanganate or carbon dioxide? Permanganate. Carbon dioxide is a very weak oxidizer, so this is stronger, this is weaker based on experience. You know?
So we have run.
Yeah, we exhale CO2, but we don't really worry about oxidizing the heck out of everything. But you aren't drinking permanganate. Even though it looks like grape juice, you don't drink it. Ethanol versus manganese 2 plus. Which one do you think is easier to burn, ethanol or manganese 2 plus? Ethanol. So this is stronger to weaker. We have driving force here based on experience, not on the chart. And so this just comes strictly from all right, so we have driving force. So what we're going to do is we're going to simplify next.
Does somebody need this?
So simplifying this, let's combine things. So over here I have, let's see, I have 15 waters here, right? And I have 48 waters here. So what I'm going to do is I'm going to get rid of 15 and then change from 48 to 33. Okay, and then I have 96 H plus here, and I have 60 H pluses here. So I'm going to get rid of all 60 H pluses there, and then drop the 96 to 36. Okay, can I simplify anywhere else? No, it doesn't look like it. And so overall, this is going to be the equation I'm going to be left with. 12 permanganates plus 36 H plus 5 ethanols produces, ethanol is a liquid, by the way, produces 12 manganese 2 plus 33 H2O liquids plus 10 CO2 gases. We have to put in the states there. If you don't put in the states, it's a very bad habit to get into, especially in Chem 1A. It makes a huge difference in energy calculations, depending on what state, you know, gaseous state versus liquid state versus solid state. All right, how do I know I didn't make a simple mistake? Well, I checked the balance. 12 manganese, 12 manganese. 12 times 4 is 48 oxygens, plus these 5 is 53 oxygens. 33 plus 10 is 43, plus another 10 is 53. So the oxygen balance, 36 hydrogens plus 15 plus 10 plus 5. 15, 10, and 5 is 25, 30. So 66 hydrogens, 66 hydrogens. 5 times 2 is 10 carbons, 10 carbons. So we're good. The atoms are balanced. Then we check if the charges are balanced. Minus 12 plus 36 gives us plus 24. 12 times 2 is plus 24. Everything else is 0. So the charges are balanced. So this is good. This is what the NIE for the reaction of permanganate with ethanol. Okay. This question was, I gave this question on the final exam last semester, and yeah, a number of people got it right. Like maybe about 5 people out of a lot of people. Most people got it wrong, of course, but a lot of people got it right. This one is super challenging.
Were you
This one's not
recording?
easy.
Were you recording?
Yeah, I recorded this. Okay, we're out of time, so we're going to continue the quiz next time then.